All right, so next we're going to talk about what's called the power rule. And so you may remember from exponents, if we have a base to a power, and we raise that whole thing to a power, then you just multiply the exponents. So like if we have 2 cubed, and we square that thing, we get 2 to the 6th. Okay, so the log rule has kind of the same, well, it has an equivalent, and that is if you have a log base b of a number to a power, then we're going to take that power and we're going to move it out front, or we can move it out front to make it n, to whatever the power is n, times that log base b of m. Proof for this one's a little more complicated, so if you care, go look in the textbook. But I'm not going to make you memorize it. Okay. So, for instance, and this is a big one, this comes back again and again through calculus, through differential equations, through basically any math that you might do after this except trig. So we've got ln of y to the 5th. So it's basically our power rule. So this is when you have log of something with a power, you take that power and you pull it out front. So we've got 5 ln y. If I had log base 5 of x to the 3rd, we would have 3, we're just taking that 3, moving it out front, 3 log base 5 of x. And if we had log of square root of a, we would say, okay, that is log of a to the 1/2. And we're going to take, we're going to take that, hold on a second. There we go. We're going to take that 1/2 power, and we're going to move it out front, right? So 1/2 log of a. And all of these things are tools in our toolbox to solve equations that have logarithms or exponential functions in them. Okay, so we'll go ahead and tell you the quotient rule, and then we'll do some examples probably in the video after. So our quotient rule, if you'll remember our with our exponents, we had, if we have same base, so b to the m over b to the n, we subtracted the powers, right? So if we have 2 to the 6th over 2 to the 3, we're not going to go figure out what those numbers are. We're going to say, that's 2 to the 6 minus 3. That would be 2 to the 3, and we'd know that that's 8. Okay? So, but really, this is one of those, you don't really need to remember this one, because we can say, oh, well, b to the m over b to the n, I can write that as b to the m times b to the negative n, right? Because that's what a negative exponent means. And then I've got, well, power, product rule, add the powers. M plus negative n. Okay, so here's our same sort of story here. Log base b of m over n being log of base b of m minus log base b of n. So this is the log of the numerator minus the log of the denominator. And this one's, again, another one where you really don't need to remember it, because we could say, oh, well, this is log base b of m times n to the negative 1. And we could say, oh, well, there's product rule, log base b of m plus log base b of n to the negative 1. And then power rule, so log base b of m, bring that negative 1 out front of that log, and you've got the same result. But that's 2 steps instead of just 1. So, you know, it's up to you. It's up to you. So this first example here, log base b of 76 minus 13 over 13, we would say log base b of 76 minus log base b of 13. Of course, that doesn't do much for us because we don't know what either of those numbers are. Same story with the second example here, ln of k over 2. We'd say, oh yeah, ln k minus ln 2. And that one's something that might pop up a little more frequently. Okay, so now we're going to jump into some more complicated examples, but we're going to put that one in the next video.